Okay, on number 11, we are going to graph a piecewise function. So we have a function here that is defined by two different expressions depending on your x values. So we have this expression, x squared plus 3, if our x values are less than or equal to 0. And we have this 3x minus 1 if our x values are greater than 0. So I like to make myself two t-tables for this. So the first one is going to be for the x squared plus 3. And here I'm going to plug in x values that are less than or equal to 0. So 0, -1, -2, maybe -3. How many do we need? Just think about this graph first. X squared, it's going to be a parabola, plus 3, shifted 3 units up. So that gives us a picture in mind what we're going to get before we even start graphing. Plug in these x values into x squared plus 3. Do it on your calculator or in your head. When x is 0, we get 0 plus 3. -1 squared is 1, so 1 plus 3. -2 squared is 4. And -3 squared is 9. That one's probably going to be off my graph, but that's okay. Notice this is x less than or equal to 0. So that point 0, 3 is going to be a closed circle on my graph that is included in this portion of the graph. Then we have -1, 4, -2, 7. And if we wanted to, we could do -3, 12 kind of off the graph up there, but I don't think we need it. Draw ourselves a nice little half of a parabola here. There's half of our piecewise function. Now we also need to take a look at 3x minus 1, and that is the part of the function we want to use for x values greater than 0. One mistake a lot of students make, they're like, oh, bigger than 0. I should start at 1, 2, 3. But we do need to include 0 as an endpoint here. The actual value at 0 is not included because it is greater than 0. But at 0, we are going to include that as an open circle on our graph, because even though we don't want to include x equals 0, we still need to include the values between 0 and 1. We can't just start at 1. So we put an open circle there at that endpoint to indicate the endpoint is not included. 3x minus 1 is going to be a straight line. So we probably don't need this many points, but let's just see what we get. 0 minus 1 is -1. 3 times 1, 3 minus 1 is 2. 6 minus 1, and 9 minus 1. So let's go ahead and plot those. 0, -1, again, open circle. 1, 2, and 2, 5. And if we want to, 3, 8, and we get a nice straight line, not continuing in both directions, only to the right, because this one is for x greater than 0. Next one, we're going to look at some operations on functions. So we have two functions up here at the top. There's f of x and there's g of x. We're going to add them, subtract them, multiply them, and divide them, and look at the domain of each one. So let's start off with addition. F plus g. We write the function f plus the function g. It's not enough to stop there. We do need to go ahead and simplify these. We need to combine them into a single fraction. To add two fractions, they must have a common denominator. So I need this first fraction to have an x plus 4 in the denominator. I can't just throw it down there. I have to multiply the top and the bottom by x plus 4 to keep equivalency. And our second fraction has the x plus 4, but it needs the x minus 2 in there. So I multiply top and bottom by x minus 2, again, to maintain that equivalency. Once I have that common denominator, I'm just going to copy it over. And then we add across the top. We add up our numerators. I'm going to go ahead and distribute as I do that, just kind of to save myself a writing step. So here I get x squared plus 4x plus 3x squared minus 6x. And you do want to go ahead and combine like terms where you can there. So x squared and 3x squared is 4x squared. 4x minus 6x, watch those signs. And there is our sum of our two functions. Next up, I want to subtract the two functions. It's going to be a very similar procedure. We're just going to have a different sign in there somewhere. So f of x minus g of x. Again, just like with addition, with subtraction, we need that common denominator. So I'm going to multiply in the x plus 4 on the first fraction minus, then on that second fraction, I'm going to multiply in the x minus 2. Now I have that lovely common denominator again. Go down a little bit here. And I'm just going to subtract across the top. Again, I can do a little distributing as I go, maybe, to save myself writing a step. I get x squared plus 4x. But be careful here. We are really distributing a negative 3x since we're subtracting this time. So that becomes minus 3x squared. And negative 3x times negative 2x becomes plus 6x at the end. Combine your like terms. This time we get a negative 2x squared on the top and a plus 10x over that same common denominator. Next up, we have our multiplication. I think that one's probably the easiest of these. We take f of x times g of x. And when we multiply fractions, that's the easy one. We just multiply straight across the top and straight across the bottom. So we get 3x squared up top. And the bottom, I'm just going to leave that factored. That's nice. There we go. Now, I didn't talk about domain yet because I wanted to wait, because the domain of the sum, the difference, and the product are all the same, okay? The domain is based on the domain of the original two functions. So we need to look at the domain of f of x. F of x is a rational function. That means we can't let the bottom be 0 because division by 0 is undefined. So we need to make sure that x minus 2 is not 0, or what that means is that x cannot be 2. Then we need to look at the domain of g of x. And we need to make sure, again, that the bottom is not 0. So x cannot be negative 4. So when we put these together, the domain of the sum, the difference, and the product is the combination of these two. We can either say, we can write it simply just x is not negative 4 or 2, because it doesn't state we have to write it in interval notation. Or if we wanted to, interval notation would be negative infinity to negative 4, negative 4 to 2, and 2 to infinity. That's how we would exclude just those two x values. Then we still need to do the quotient. We need to divide. So if we want to do the quotient of f of x and g of x, that would be f of x divided by g of x. And this is where we have to remember that the division of fractions is the same as multiplying by the reciprocal. So we flip that denominator upside down. And again, multiplication, we multiply across the top and across the bottom. This time I would not distribute because we want to simplify. And in order to simplify, we need the top and the bottom to be factored. And so when I write it like this in its factored form, I can see right away that these x's are common to the top and the bottom, so I can cancel those. And there's my simplified answer for the quotient. Now the domain of the quotient starts with the domain that we had for the sum, the difference, and the product. So still, we have to make sure x is not negative 4 and x is not 2. But also, because we are dividing by g of x, division by 0 is undefined. So we have to make sure that g of x is not equal to 0. So to solve that one, we'd multiply both sides by x plus 4. So we get 3x cannot be 0. If We divide by 3, we get that x cannot be 0. So for the domain of our quotient, we have to throw in there also x cannot be 0. Number 13, some more operations on functions. This time we move on to our composite operation. We want to figure two things. First, we want to find f of g of x. That little circle is our composite operator. So f, the function that comes first, is going to be our outside function. And then g, the function that comes second, is our inside. I just start by replacing this label, g of x, with the actual function g of x, which for this problem is 3x squared minus 2, just a replacement there. Then I need to go and now look at the function f, okay? F says the square root of something plus 7, something being my variable, that's where my input goes. And for this one, my input is 3x squared plus 2. Now we can't do a lot of simplification, but we can do just a little bit here because we do have like terms. 3x squared, 2 plus 7 is 9. Now what you can't do is take the square root of each of those terms. These are sums, so we cannot take the square root of two separate terms like that, so we leave it just like this. There's our first composite. Second one, we want to turn it around and find g of f of x. So now this time g comes first and f comes second, so it's the inside function. So g on the outside, replace the label f of x with the actual function f of x, which is the square root of x plus 7. Then we want to look at the function definition for g. G is 3 times something squared minus 2. Right up here, that's where I got this. In this case, the something, the input is our square root of x plus 7. And again, we can do some simplifying. The radical and the exponent, those two cancel each other out. So we just end up with 3x plus 7 minus 2. We distribute that 3. And then combine our like terms. So 3x plus 19 would be our final composite result. Number 14 is also a composite question, but they just used a little bit different notation, a little different symbols. Instead of using that little composite notation with the little circle, they just stated it, find f of g of x. So we will do the exact same work that we did above. So f of g of x. Start by replacing g of x with the definition of the function for this problem. There we go. Then we're going to take a look at f of x. That says take 6 times something squared minus 5. Our something in this case is what we have in the parentheses. That's the 4x plus 7. We do want to go in and simplify this. Be careful. Let's do our order of operations. We are going to square before we multiply. So do not start trying to distribute that 6 in there. Leave it alone. Leave it out front. But we can go ahead and square this out. So if you need to see it, write it out so we can FOIL it. 4x times 4x is 16x squared. And then we get a 28x, another 28x, and 49. I will combine those like terms in the middle. 28 and 28 is what, 56x? Now we're ready to distribute that 6 through. Oh, I'm going to use my calculator for that because I don't do a lot of math in my head. Isn't that terrible? 6 times 16 is 96. I probably should have known that. 6 times 56 is 336. And 6 times 49, 294. Don't forget we have that little minus 5 hanging on at the end. So we do want to make that final step of go ahead and combine those constants at the end. Those are our like terms. 96x squared plus 336x. 294 minus 5 would be positive, what, 289. There is our first composite. And again, it asks us to go the opposite direction too. So we also want to find g of f of x, which means g is first. So that's our outside function this time. F of x is second. Oh, I don't need to write that. That's already how we wrote it. We are going to replace f of x with the function itself, 6x squared minus 5. Then we look at the function for g, which says 4 times something plus 7. What we're putting in for our input is our 6x squared minus 5. We can go ahead and distribute that 24x squared minus 20 plus 7. Combine our like terms, 24x squared minus 14. Nope, 13. Always check your math. There we go. There's our next composite. Number 15, we move on to inverses. Find the inverse function, and they gave us a nice little f of x here. So remember, the basic idea when we're finding inverses is we want to swap our x values and our y values and then solve for that new y. So remember, f of x, that's a y value right there. That's the same thing as y. So we want to replace that with x. This x we want to replace with a y. So we just swap them. And we're going to solve for this new y right here. So first step, let's add 2 to both sides. On the left, we can't combine those. We just write it out as a sum. Next up, we need to deal with that exponent. The way we get rid of an exponent when we're solving is we use a radical with the same index. So it's not a square root, it is the 5th root. So on the left, we have the 5th root of x plus 2. On the right, the 5th root and the exponent cancel each other. We have y minus 3. So then our final step, add that 3 to both sides. Notice on the left, we have a radical and the plus 3. Those are not like terms, so we cannot put those together. We can't put the 3 under the radical. Oops, as I'm saying 3, I wrote a 3. So it's the 5th root of x plus 2 plus 3, not under the radical symbol, equals y. There it is. When you write your answer, do not just write just the expression. Make sure you set it equal to, you can call y equals, or more correctly, it would be the inverse equals. Make sure you label it. Okay.